In the deepness of space, the cold and darkness surrounding you light a flickering signal of another part of the universe, the only thing surrounding you, your thoughts, grievances, and the notion of your existence. And in that empty space, a voidless pit emerges, so deep that it almost seems as deep as my need for a stinking hamburger right now. The voidless pit is infinitely dense. Matter pressed together so hard that it becomes a death trap for everything that passes by it. Black holes are incredibly strong beings. Their gravity is so powerful because of the denseness of their bodies. They can suck anything up in their mighty trap, and you are never getting it back. Except for in Hawking radiation, of course. Black holes, because of their immense power, hold anything against the restraints of entropy for trillions of years, seeing the passing of time, the dying of planets, the great darkening of the cosmos. They will be there sometime as the last beings of matter left in the world at the death of the macrocosm. Black holes are here to stay, and they are here to stay for a long time. But how do they work? What are they, and why are they so unusual? These are all questions that we will answer in this video. Anyways, before this video begins, this video took hours of work, so if you could hit the sub button, it would help me stay motivated. Anyways, on with the video. Black holes by definition, quoting Britannica, a black hole, cosmic body of extremely intense gravity from which nothing, not even light, can escape. Black hole is made like this. It is formed when particles of hydrogen form a large cloud and pull together because of gravity. It is so hot that it fuses the hydrogen and uses that as a fuel to keep bright. After billions of years, after it explodes into a beautiful but cataclysmic supernova, the colors like a modern art piece, after the star gets to the Chandrasekhar limit, it enters its final stage. The Chandrasekhar limit was hypothesized by Subramanian Chandrasekhar. I'm sorry about the pronunciation there. He believed that once a star got to 1.5 solar masses, which a solar mass is about the weight of our own sun, it would collapse under its own gravity. It would become a void in reality, a patch in what us humans could consider a place travelable in the universe. How large these pits of death would be? Well, you can find that by using the Schwarzschild radius. This equation can calculate what any mass will recede to if it becomes a black hole. The ratio of original matter to a black hole is so small that if the Earth was turned into a black hole, the Schwarzschild radius would predict that it would turn into a black hole the size of a peanut. A person would be reduced to the size of a nanometer. These sizes might seem very small. The stars that are imploding like this are many, many amounts bigger than this. If something 1.5 times the size of the sun became a void, it would be millions times bigger than that peanut, ranging up into planet-size black holes that would only expand when the planets and everything else went into them. Black holes are scary things. I don't think I have to tell you that twice, and they should be taken seriously, as they could. I know, I'll stop talking about multiverses after this episode, but these black holes could lead to multiverses. A black hole's size is measured by its event horizon, or the point where you enter the black hole, and the point of singularity, the part where there is no return. This is when you get to a point of infinite density and heat in the middle of the black hole. Mathematics say that it would be impossible to get past this point. However, some scientists think that the black hole goes past the singularity. One of these people is Einstein, and he combined his thoughts into the theory of the Einstein Bridge theory. That's a mouthful. This bridge is a bridge between worlds. Einstein thought that past the singularity point, there is a point that is opposite of the universe that we are in right now. The colors are opposite, the antiparticles are normal particles, It sounds like science fiction, and it quite possibly could be. But if it is in fact true, it could be another thing for Einstein's resume. What would happen if you tried to pass that barrier? And it turns out that there is no Einstein Bridge. Well, you'd be done for, of course, but in a lot more of a creepy and ridiculous way than you think. As you approach the black hole, you would start to feel a large gravitational pull. The light would be wonky and distorted, and you would feel yourself being ripped apart. As you neared the point of no return, your being would be ripped apart by the pull of the black hole. You would be chomped into the black hole, a burp later emitting a little Hawking energy. You'd find out Einstein was wrong. Hawking energy is something theorized by the light physicist Stephen Hawking, a major influencer in the scientific field. Hawking radiation is when particles leaked into a black hole on an opposite end, small particles would leak out. Since all particles have antiparticles, if the popping occurred at the event horizon, the black hole would lose a small amount of mass. He thought that this happened to a black hole every 10 to the 100th years. He also created the theory that the entropy levels of a black hole were equal to the mass of the black hole, a thought that would change the way we think of entropy in many ways. In conclusion, black holes are scary, powerful, and impressive bodies, and they should be researched, for they could be important in our knowledge about the universe in total. Anyways, that's the end of the video. Thanks for watching, and see ya.